it is to identify a value between two values. Okay. Okay, in my class, if you don't understand or you need me to repeat, just let me know. Okay, I can repeat max 3 times. More than that after class. Okay. So I just ask question. I prefer two-way communication in class. If you don't understand, just ask. If you are not sure, ask. If you want to challenge me, also can. Not sure. Okay, because engineer, we should have critical thinking. It's not a passive. You should ask why you need to do that. Why you need to know this thing. Okay, numerical. Basically, now in this class, you will learn about fundamental, basic. But in your next, I think you have numerical lab. That one you will apply those. Currently, the industry now, we use software, MATLAB, or all those things. So basic is the numerical part. Okay. Now, so we go for interpolation. For interpolation, you will have later on two types of interpolation, which is Lagrange and also, Newton and also Lagrange. Newton and Lagrange. So today I will teach you about Newton. Newton divided difference. Okay, the names. Now, interpolation basically, if you have x and y value, let's say 1, 2, 3. Okay, let's say this one 0, 0.1, 0.3. But you are required to find value for y for x with 2.5. Okay, you are required to find the unknown value for 2.5, for example. So we need to do interpolation between this value and this value. Okay, same concept as your slope. You want to find your slope. Okay. Okay, let's say you want to find for y for x equals 2.5. Okay, so you need this value 2, 3, 0.1. Okay, so for interpolation, in order for you to find this, you need to do the interpolation. So there are two methods, Newton and Lagrange. In your statistic, you just learn a simple interpolation in your statistic, which interpolation for statistic would be 3 minus 2. So this is your unknown, your y minus 0.1, 0.3 minus 0.1. So from here, you will find your y. Okay, so this is simple interpolation. But numerical way, we use Newton and Lagrange. There are a few orders from 0 order to n order. Okay, but this is the basic interpolation. Okay. Now this is, let's say you have some polynomial, this kind of curve. Make it bigger. Okay, this kind of curve. So you have these given values of point, but you need to find out the unknown value here. So you need to do the interpolation. This is the unknown x, unknown value. Okay, so you need to do the interpolation. Now for the interpolants, most common because they are easy to evaluate, differentiate, and integrate. There is also integration involved. Okay, for polynomial function, this is the basic one, polynomial function, where you have b0, b1x power 1. Okay, this one is power 1. Power 1 means what? Linear. Okay, it is a linear function, power 1. Let's say you have a linear function, which is your mx plus c, right? So this x is power 1. Your b1 over here, b1 is equivalent to the m, the slope. Okay, so as it increase the order we focus here, this is the order. So linear order 1, n equals to 1. Okay, for quadratic, n equals to 2. So this one is the n value until n order. Okay. Okay, here n equals to 0. N equals to 0, which over here in front here. Here it means you have only 1 point. Means let's say you have a polynomial function. So n equals to 0, 1 point, which is the starting point. This one equals to fx naught, your starting point. Okay, n equals to 0. Where linear, you should have 2 points. Okay, 2 points. So x naught, x1, 2 points. Then only you can have a linear line, right? If only 1, you cannot have linear line. You need 2 points. Okay, so if n equals to 2 means you have 3 points. So when 3 points, it is a quadratic equation, 3 points. Okay, n equals to 3, 4 points, cubic equation. Okay, so whenever you are given the polynomial function, you must see until what order. And at that order, what is the points? How many points includes? Okay, if let's say the question asks you to do interpolation until n equals to 3. So you must have 4 data points. And you must identify what are the points. Okay, later we do exercise, then you will understand better. Okay. Now this one, the figure over here, I extract from the textbook. Linear interpolation, which is n equals to 1. Okay, so n equals to 1, you should have 2 data points. 2 data points. So x naught, x1. Okay, this x naught must have its own y value. That is the 2 points. Okay, so linear, the polynomial function up to here only. B naught plus B1x. Okay, n equals to 1 means that f1x. So the equation involves up to B1. So x over here will change to this, x minus x naught. This x is your given x. Okay, let's say it asks you to find interpolation for n order, 1 linear, okay, n equals to 1 for x equals to 2. Okay, at x equals to 2. So this x is 2. Okay, B naught equivalent to fx naught. Okay, let's say you have this curve. Okay, this curve. For linear, it will involve x naught and x1. 2 points. X naught, x1. So you need to find the fx when x equals to 2. Okay, so this at this point is your f1x, fx for n equals to 1. Okay, linear. So you need to find what is b naught and b1, then subs into the equation. Okay, b1 over here, basically here, the m equation, the slope equation. fx1 minus fx naught over x1 minus x naught. Okay, the slope. The other one is for n equals to 1 for linear. Okay, now I want to show you for the rest of order. The rest of the order. Let's say f, okay, this is your polynomial function. This is common. General one, b1 x plus b x power 2 plus b3 x power 3. Okay. Your level usually question will ask up to n equals to 3. Okay, here bn x equals to n. Now for f1x just now, n equals to 1. It should requires up to b0 plus b1x. Okay. Now b1 over here is your, b0 is your fx0 or y0. Okay. b1 is your slope, which is fx1 minus fx0 over x1 minus x0. Okay, the one is n equals to 1. Now, how if n equals to 2? When n equals to 2, then your function will be up to here. Okay, let's say f2x. So b0 plus b1 x plus b2 x power 2. Okay, now b1 same. The equation is the same. Value, it depends on your data point. Huh? So for your b2, okay, b2, here I continue for b2. Now for b2, you have, okay, if n equals to 2, how many data points that you should have? 3, right? Okay, n equals to 2, you should have 3 data points. Okay, so it involves x0, x1, x2. Okay, and fx0, fx1, fx1, and fx2. Okay, so these are the data points involved. So for your b2, how to find your b2? Find each slope. Okay, it involves each slope. Between 2 points now, fx2 minus fx1 over x2 minus x1. Okay, then minus between x1 and x0 value. Okay, x1 minus x0 over the whole thing. X2 minus x1. Okay, let's say you have this one, you have a function, and then you are required to find the fx value with second order. Okay, so this is your x0, x1, x2. Okay, so you need to find the slope for each. B2 over here. This part, between x2 and x1. So it involves this part. minus the slope in between this. Okay, x1 and x2. Then it divides the whole distance from x2 to x1. Sorry, x2 to x0. Oh yeah, sorry. Here should be x0. Sorry, my bad. x2 minus x0. The total distance between x2 and x0. Okay, clear? That one is to find B2. So once you get your B2, subs into the value of here. B1 from the previous equation. Okay, this equation. B3 even complicated. Okay, when you have 3 points. Sorry, n equals to 3, how many data points? 4, correct. Okay, so for 4. Now for B3, I think I have the slide. Here, B3. B3, when you have 4 data points, x0 until x3. Okay, so you must find B3. Now B3, much more complicated because it involves between 4 data points. Okay, let's say you have 4 data points. So you must find the slope for each with divided the whole distance. This equation will be given in your test or final exam. Okay, this equation will be given. But you should try to do in order for you to know how it come up with this equation. Okay, do from 1 point to 1 point. Okay, let's see. This from x3 to x2. Okay, so the slope at this point. Then it minus slope from x2 to x1. Okay, so it divides between this region. Next one, between x2 to x1 and x1 to x0, between these two regions. Okay, then it divides the whole region, the whole distance. Okay, that is the concept on how to get the B. Any questions so far? Let me know if I go too fast. What's your name? Sorry? Huh? Abdullah. Can you understand?
Yes.
You didn't write anything? Then how you understand? Why later? Why not during the class? Later we do example, please try to do. Okay. Okay, in my class, please do and try. Maths, you need to practice. This is not theory.
Whenever we write an exam or in our test, they consider marks.
Derive the equation.
Writing a bit, yeah, these functions, they have marks.
No, this one will be given.
marks you can allocate after you put the value.
Yes. Marks given after you put the value and the value is correct. Okay, in numerical, usually it is a straightforward question. You just need to know which method to use and which data point to sub into the equation. Most of the time, the mistake student will do is the wrong selection of data points, which eventually will have wrong value. So your calculation overall will be wrong. You will get marks for the stats only. Okay. Okay, now we proceed with the example so that you can understand better. Now this example, it asks you to estimate the natural log of 2 using linear interpolation. Okay, linear interpolation n equals to 1. So you need 2 data points. In this question, it gives you n equals to 1 and 2 data points. Sometimes in final exam, usually in final exam, I won't give this info. You must know linear n equals to what? Quadratic n equals to what? Okay. Now, first, you need to perform the computation by interpolating between ln 1 and ln 6. So this is your data point, ln 1 and ln 6. So your x0 is 1, x1 is 6. You are required to find 2. Your x equals to 2. Okay, log 2. Okay, then it asks you to repeat the procedure but use smaller interval which 1 and 4. For each case, calculate the true percent relative error. So if the question asks you to find true error, you need to find the true value first. How to find the true value? Huh? That is the equation of error, but the true value is from calculator. True value is from calculator. You just press ln 2. That is your true value. Okay, because what we will do later on is using numerical way. So ln 2, you will get this figure. Correct, right? So this is your true value. Okay, so I would suggest you to do table like this. X, data point for X and Y. Okay, so your X is equals to 1 and 6, where ln 1, press the calculator, you will get 0. Okay, now ln 2 using n equals to 1 order. Interpolate using n equals to 1 order. So you need to identify the function. After you identify what are the data points, identify your function involved. So F1, 2, it involves B0 plus B1x. Okay, so B0 is your Fx0, which is the Y0 over here. Okay, this is your Fx0. So B1, you need to calculate using the equation. Okay, so using the equation, you find the B1. Fx1, press your calculator as well. You will get this value. Okay, so for your B1, you should get this 0.4621. Okay. B1. That is not the final answer yet. That is only for B1. So subs your B1 into the main equation over here. Okay, I want to highlight on the X. X over here. So here, once you sub your B1, this part will be X minus X naught. X is your given value, which is 2. X naught is your previous value. Okay. So subs into the equation. Do you get 0.3584? Sorry, not X naught, X1. Sorry, X1. Sorry. Correct lah, X naught. The value is 1. Here, X minus X naught. Okay. Anyone need me to repeat? Okay, take your time to digest. So for the true error, the true value just now minus your approximate value. So true value, which is this 6932 minus your calculated value 0.3584.
So true value minus by the approximate value. Very different. B1.
Correct, yes. Approximate value over true value. Okay.
Not sure which one to start.
Not sure which one to start. Okay, we do it here. Show it here. Now this one is for the first one. X01, X16. Okay, so we need to find, first thing, identify your equation. F1, 2. Okay, this should be the first step. So that you know you need to find until what B. Okay, so B naught is equivalent to Y naught or Fx naught, which is 0. Yeah, this one. Okay, 0. Then B1 using the slope equation, which is Fx1 minus Fx naught over x1 minus x naught. Okay. Now, this value, how you get? Press your calculator. Okay, the y value for 6. press your calculator, you will get this value. So fx1, which is that, minus fx0, which is 0, kx16 minus 1. Here you will get just now 0.4621, right? All get the same now, or different? Wait.
0.31.
Yeah, sorry. 4621 is for x1 equals to 4. Sorry, This one should be 0.3584. Okay, so then after you get all the values, subs into the equation. B0, which is 0, plus B1 multiply. Okay, this part, remember, this is x minus x0. Okay, x is 2, x0 is 1. So you will get 0.3584, same. Okay, so this is your final answer. X over x0. Sorry, not over, minus x over x minus x. Okay. Okay, so the true value, sorry, the true error. So true value minus approximate value over true value times 100. So your true value just now, the one that you press from your calculator, which is 0.6932, minus approximate value, the one that you calculated, okay, over the true value.
It's always x minus x2.
Yes, x minus, okay, this one for n equals to 1, x minus x0. If n equals to 2, different. Later we go. Okay. Okay, try when you have points, when you are given point as 1 and 4. When your x0 equals to 1, x1 equals to 4. Will you get this answer? Same step.
is like two, like it's like in interpolation, you get two values and one of them 101%, the words are going to be one versus pretty much like in the middle. Then the financial value, approximate value, all that stuff get the true value, the error, yeah, it's like
It's straightforward.
okay.
Yes.
Yeah. So that's value. Something like that. So what you need.
Okay, easy, yeah? This one, n equals to 1. Now, when you calculate just now at a smaller range of data, first is 1.6, then 1.4. So you will see the error is reducing. Okay, so the smaller the scale, the smaller the error. It is approaching the true value. Okay, as depicted by this figure, when you have this one is for, okay, this one when you have 1.4, then 1.6. Okay, you can see the two different value for the linear estimation. So this one is approaching to true value. Okay, yes. For this one, x minus x naught. So 2 minus 1 as well. 4 minus 1. No need.
Previous one, like minus one.
Okay, okay. I know what is confusing you. Now, this equation, okay, when it comes to linear, x minus x naught, doesn't matter what is the value. So x here is the given. In this question, you are required to find ln 2. So x here is 2. X naught is your previous data point, which is equals to 1. Okay, so in the next example, 1, 4, same. Now your question when to include 4 minus 1. This one, for linear, it doesn't involve. Okay, 4 minus 1, perhaps this part. When you want to find your B1, then 4 minus 1, the distance, because it is the distance between 4 and 1. So that's why in this example, your B will be different, 0.4621. Okay? For x value over here, it always x minus x naught. Can do this.
It's like the middle part. I going to perform that one final F1 4.
No need. F14 no need, because the question asks you to find F12. F12 only. No, no need. We just need to find the true value for F12 for this question. 1 and 4 is your data point. If you want to find F14, then you need to have another data point after 4. Let's say 6. That's different. Okay, I repeat. For n equals to 1, which involve only 2 data points. Okay, 2 data points. So, from this figure, 1, 6. So, from point 1 to point 6, what is your y value for 2 when your x equals to 2? So, you need to find. Yes, here, 2. 2 over here. So, what is your x? What is your y value when your x equals to 2? Okay, so for range data point 1, 6, you will get this. But when the range 1 equals to 4, you will get this value. 1 and 4 is your data points, not the one that you need to calculate.
For F1, 2. B0, F1, 2, B0 is equals to 0. Right?
Correct, yes.
Fine. Yeah, no, that's fine.
B1, sorry, B0.
B0 is 0.
B0 equals to 0 because B0 is equals to Y0. Because you have the same data point. 1.
B0 also equals to ln 1.
Yes, ln 1.
So So let's say that other questions, for other equations, let's say, for B0, or it's gonna be like a different value. So different values, say 3 or 5. Substituting to the F1, 2, that's B0, it's gonna be like a different number, right?
Yes. Okay.
So it's really correct this one.
We answer this. What?
Questions to the maximum of the number. So that's B or
Usually your level 3 up to n equals to 3. Yes, do this. Yes. The question is 2. You want to find long 2.
1, 6, and 1, 14. Find
2. Yes, correct. Okay.
So it's the error.
Yes,
I need to see that.
correct. Okay, so it means like to find the center point. Let's say from this end to that end. Center point is there. So you move that end to the second table. Center point will lesser, different value. Okay. Okay, now we move to n equals to 2, where you should have 3 data points. Okay, n equals to 2, quadratic. Quadratic is n equals to 2. So you should have 3 data points. This one you should know first. Okay. So your equation, polynomial equation, will become until B2. B0 plus B1x plus B2x power 2. Okay, so this for linear, this x will form x minus x0. Okay, now for quadratic, this part, it will form x minus x0 multiply x minus x1. Okay. So B0 same equals to fx0, whatever value. It is not compulsory to be 0. Okay, your B0. So B1 from the equation, calculate from the equation. B2 is also calculate from the equation. Okay, so we move to next example. Now it asks you to fit second order. Second order n equals to 2. So you should have 3 points used in the previous example. Here it gives you x0 0.5, x1 4, x2 6. Okay, so we do step by step. Now put it into table form. Okay, always put it into table form so that it will be more organized. Okay, so this is your x0, x1, x2. This is your, you are required to find ln 2 as well. But now n equals to 2, polynomial. So press your calculator for x0, x1, x2. This is your y0, y1, y2. Y or fx, same. Okay, don't confuse yourself when I use y or fx. It means the same thing. Yes, y exists. Okay. Okay, then from this data point, we know that f2, 2, b0 plus b1 x minus x0 plus b2 x minus x0 multiply x minus x1. Okay, so these are the equation involved. The main function. Okay, so B naught we already get from Y naught, Fx naught. So B1 now, you need to find B1. B1 is Fx1 minus Fx naught over x1 minus x naught. Okay, so here it will be this, between these two values. Okay. B1, what you get? Right, 0.5942. Okay, this is your B1. Then find your B2. It's smaller first. Okay, so B2 between x2 and x0. So fx2 minus fx1 over x2 minus x1 minus between x1 and x0. Okay, x1 minus x0, then over the total distance, x2 minus x0.
Normally the questions would be like this.
What?
Normally the questions would be like this style.
Yes, this style. But it, for final exam, usually it will be in case study question. Later we'll try to do. What you get for your B2?
Negative 0.0711.
Correct. Yeah.
Okay.
It's in the slide, but you should know how to do it as well. Okay. Okay, now once you get your B1 and B2, subs into the main equation. So your F2, 2, B naught is 0.6931 plus B1, the one that you have calculated earlier. X is 2 minus X naught. Now, X naught is 0.5 now. Okay, then plus your B2. Multiply with X minus X1, sorry, X naught. Multiply X minus X1. X1 is 5. Sorry, X1 is 4. 2 minus 4.
7.12 or 7.15.
7115. Correct.
I can't do it.
If you use 711 also 712 can, but final answer a bit different. Not much different.
It's not 2 minus 1, 2 minus 0.
Oh yeah, sorry, correct. Yes. Sorry, this one should be 0.5. Sorry. Thank you for that. Okay, when it involves numbers, confused. 0.5, huh? You get 0.4116. If you round up earlier for your B2, doesn't matter. But later on, I think F2, you will get a slightly different value lah.
This is I think it's quite fixed. The other is 5. 4.46. How do we purchase it?
It depends to the order. What order that you need to use.
0.4.
That one, it will give you the data points. It's either directly give you the data points or you need to select.
It's not the next one going to do that. Yeah, I'll get used to it. No. But you know, I think mine is basically C1.
B1 linear. Sorry, I cannot get your question. If we have 3 data points, then it's not good anymore. It's not same. It's the main function. Then X then B1 and B2. B1. If we use this, that's not this. Whatever text it is, it's not essential.
And this is the same thing, right? Oh my God, McDonald's that's certain. Then there's going to be a true value minus the. This is the hockey that I do this. That's a okay. Two values like that's not very involved. That's part of the actually one. So they have that almost to be and right. Yeah, the equation for one year for the second. Function. Yeah, yeah, yeah. First one.
The function, I will give you the general function. So you need to know what is your B1, B2, B3. Okay, this one true value you already know the true value. You can just straight away find your calculator. But in your real engineering, you don't know the true value. So if there is no true value, you will find the approximate value. The approximate error should be lesser. The lesser the approximate error, the more accurate your value. Okay, like you do the iteration previously. Newton, Raphson, Gauss-Seidel, everything. You do the iteration, right? That one is based from your approximate value, right? Okay. Okay, this one, this figure, it depicts this example where your n equals to 2 quadratic. Okay, quadratic. So this line, the quadratic line. So estimation, the error, what's the error? So you find the error, the true error. Is it lesser or same? How about the true error? Try to calculate. 79. More than linear. Or get 79. Sure.
Like 40.6.
40.
40.6.
40.6. The rest get 40.6. Okay, the true error 40.6 roughly lah. Okay, so comparing the linear order and the quadratic error for this issue, for this example, not much difference that you can see. Okay. Okay. This one is the same. Okay, this one, it also explained to you how from fx, first order, second order, and third order. Okay, you can also do this iteration way, or you can find using the B1, B2, and B3 equation. This one you can do iteration way. Okay, so to find your B, this one B1, B2, B3. So B3, it involves 4 data points. N equals to 3, so it will involve 4 points. Okay, instead of using the equation, the long equation of B3 just now that I shared earlier, you can use this kind of iteration. Okay, so in which your B2 over here, okay, this one minus this over the total distance. Or you can straight away subs the value in the long equation. Okay, there are 2 ways to find B3. Okay, using just now example, it is n equals to 2 until B2. Okay, so let's say just now, your B1, the value that you get previously is Just now is 0. Okay, and then this is 0.5942. Okay, so using this value, divide by the distance, then you will get your V2. Okay, this one you can try. But in my class, usually I will advise to focus on the equation given. Just subs in all the equation. Okay, this one you can try later on your own time. Now, we move to this example where now you have 4 data points. N equals to 3. Correct, yes. 4 points. Still to find ln 2. But now you have 4 points. From 0.54, now you add 5 and 6. Okay, the higher the order, the higher the accuracy. Yes, more data. Correct. The higher the order, the higher the accuracy. Okay, if you remember, I think in first lecture, I don't know, I'm not sure whether Dr. Ng explained about how to predict the COVID trend.
But it's the equation's so big. Can we do something else?
What?
The equation's so big.
Yes, manually you will see like that.
Is there a shortcut?
No shortcut.
It's like too big. Let's learn about something else, please. Fine, okay, I'll do it.
No shortcut, but up your level, I will ask question up to n equals to 3 only. Okay. Usually, if you have a lot of data, that one you need to use the software. Okay, no point to do it manually. Just subs into the value. Okay. Yes.
That's not fair.
Yes, it depends to the data points arrangement. Okay. Now I want to summarize for the n equals to 3. Since it involves a long calculation, I will summarize first. We are running out of time. Huh? So next class, we will do the previous final exam question style. So now I conclude. So let's say interpolation of ln 2 with different order of Newton's interpolation. This is Newton's. Okay. Now first order, just now you get this value with this kind of true error. Second order, smaller error. Third order, you'll get this value if you try. So from here, you can see the true error is decreasing. The higher the order, the lesser the error, because you have many data points.
Like converging?
Yes, converging. It should be converging. If you find out your error is diverging, then something wrong with your data point. Yes. Okay. It must approach the true value. Okay. Yes. Correct. I'm not sure which order will get 0%. Okay. Now that is about Newton's interpolation. It used the order B0, B1, B2.
The same we did. Last two examples.
Which one? Jacobi.
Yeah.
Different. They want iteration. Okay. Now this is the final exam question. Okay, final exam question will come up, might come up like this style. So it gives you the case study. with a lot of data. Okay, now this question, it asks you to, where's the question? Apply third order Newton. So n equals to 3. That means you only need how many points? 4, right? 4 points. But you have a lot of points over here. So you need to select it correctly. Which data point? So you're...
For this one,
Mm-hmm.
the correct way is to choose for them together, really close together.
Close together.
For them really close together.
Yes. Correct. For this one, at day C. Okay, day C. C here is 2 to 5. Okay, C is 2 to 5. C here is your X lah, so your day. So 2 to 5 is in between this point, correct? 2 to 5.
The 4 points would be starting from 190 to 55.
Yes, you will have a few sets of data
Choose
points.
these 4.
Correct.
So we can go down first. Do that interpolation.
4 data points. So you need to do is either, okay, 4, these 2 must include. So another 2 is either above and below. So this can be your data point, the first choice. Or you can also choose this one must include. This one, X. Okay, so different data points, you will have different final value. 4 data points only. If you choose all, then your answer will be wrong. Okay, that's why when you list your data point also, you get marks. The correct data points. F3, 2 to 5. Now you don't have true value over here. So you only, I think this question, it doesn't ask you to find the error. Find the F3, 2 to 5. X. X is 2 to 5 here. X is your unknown. This one is, no, sorry. This one just ignore because this question during COVID time. So during COVID time, each student must have different value of C according to their ID number. Because we don't want them to have same answer. Correct. Yes. Your style of question will be given only one fixed value. Okay. Okay, so tomorrow we'll proceed with this final exam question. Okay, so that's all. Thank you for today. For those who haven't scanned, you can scan. Wait,